Hi everyone, it's Mr. Barbier back with another video. Today's topic is multiplying using the lattice method. So, you already know how to multiply using the standard algorithm. Today we're going to multiply whole numbers using the lattice method. And then at the very end of the video, I'll show you how to multiply two decimal numbers with the lattice method. Let's start with this problem right here. 468 times 253. Let's go. So the trickiest part about the lattice method, honestly, is creating the grid, okay? And when I say grid, it looks like this, okay? So I'm multiplying a 3-digit number by another 3-digit number. So I'm going to make a 3 by 3 grid. So that means 3 rows going down and 3 columns. Okay, I meant to say actually 3 rows going across and 3 columns going down. That's what I meant to say. All right, so notice I have a square here as best as I can make it. And I'm going to create 3 columns going down. Okay, and why 3 columns? For the number 468. Now, if this was a 2-digit number, for example, 46, I would only need 2 columns, okay? If it was a 4-digit number, say 4,685, I would need 5 columns. So I need an extra column right here, right? But because it's 3-digit number, I have 3 columns. I'm multiplying a 3-digit number by another 3-digit number, so I'm going to need 3 rows going across. Okay, so 253. Okay, so again, these 3 columns correspond to the number 468, right? This column for the 4, this column for the 6, this column for the 8, and these 3 rows correspond to each digit in the number 253. This row for the 2, this row for the 5, this row for the 3. Now we're not done yet. We have to make diagonal columns, like so. So a diagonal column basically means you find a corner and you make a slanted line, right? Now look here. There's a corner here and there's a corner here. So I'm actually going to connect corner to corner and then extend. Okay? Corner to corner to corner and extend. Let's do that again. Corner to corner to corner to corner, extend. Keep going. Corner to corner to corner, extend. Corner to corner, extend. And then we have one more corner, extend. So this is probably the trickiest part of the lattice method, creating this little grid. So remember, the grid is made depending on how many digits there are in each number you are multiplying by. All right, 3-digit number by 3-digit number, three columns, 3 rows. Now, what do we do now? Let me zoom in on the grid. So this is the easy part, as long as you know your multiplication tables. So the way this works is this. What I'm going to do is I'm going to look at the 2 and understand that every box in this row corresponds to this 2, okay? So meaning the answer that goes here, here, and here is 2 multiplied by a number in which is being intersected going up and down in the column. So for example, since 2 is going horizontally and 8 is going vertically, the 8 and the 2 meet in this square. So therefore the answer will appear as a tens and a ones. Okay, so 2 times 8, the answer meets in this square, is what? Okay, someone just said 16, so I put my tens place here and my ones place there. Let's continue with the 2 row. So 2 times 6, the answer would go here, is what? Good, someone said 12. What about here? Again, follow the 2, follow the 4 going down. It meets here. 2 times 4 is what? Someone just said 8. Very good. So since 8 only has value in the ones place, I'm going to put a 0 in the tens place as a placeholder. 0, 8. Okay? Now you might say, Mr. Barbier, is there an order in which you have to fill in these boxes? The answer is no. You can actually fill in the boxes in any order, all right? For example, we can fill in this box right here if we want to, right? So let's see, what does this box, what 2 numbers meet here at this box? Which 2 digits, I should say, meet at this box? Well, 3 comes this way, right? And 4 comes this way. So this box is the answer for 4 times 3, which is what? Good, someone said 12. So my tens goes here, my 2 goes there, okay? And again, right, you can fill in these boxes in any order. So now let's just go quickly because we get the idea. So this box here is 4 times 5, which is what? Good, 20. What about this box here? Okay, that would be 6 times 5, right, which is 30. And this one? Okay, very good. That would be 6 times 3, which is 18. Very good. And this one? Okay, someone said that would be 8 times 5, which is 40. And this one? Okay, obviously that would be 8 times 3, right, which is 24. So filling in all the squares, easy as long as you know your multiplication tables. Please keep working on them if you're still stuck with some of your tables. Now, this next step must be done in a specific way. All right, I told you can fill in the squares any way you want, but this next step, which is addition, must be done going from right to left. We're going to go like kind of, across this way and then going up this way, right? How do we do that? We add the digits in the diagonal columns. So notice you have a diagonal column here where the 4 is, and then a diagonal column here, the 0, 2, 8, and then here, right? The 6, 4, 0, 1, 2, and then here, and then here, and then here. These are all diagonal columns. We're going to add the digits in each diagonal column. Now you might say, well, wait a minute, 4 stands alone in this diagonal column. So therefore you just drop it, right? Look at this diagonal column, 0 plus 2 plus 8. What does that give me? Okay, someone just said 10. So you might say, well, do I put 1, 0? No. Each column stands for 1 digit and 1 digit only, okay? So each column, each diagonal column, only 1 digit goes in that column, okay? So since 0 plus 2 plus 8 is 10, we're going to drop the 0, and we're going to carry the 1 to the next diagonal column. Now you might say, Mr. B, where are you going to put it? Technically, you can put it anywhere. You can put it in the 2, the 1, the 0, the 4, the 6. But you know what? The best place to put a number you carry is at the top, right? So let's squeeze a little 1 right there. So we have 1 plus 6. That's not a 16, mind you. That's a 1 plus 6, right? Which is 7, right? Actually, wait, let me stop there. Let's do what we always do. Let's look for digits that add up to 10. So we have 1, 6, 4, 0, 1, 2. What adds up to 10? Okay, someone just said, Mr. B, 6 and 4 adds up to 10. Good. So if that gives me 10, let me leave those 2 digits alone and add everything else. So 2 plus 1 is 3, plus 0 is still 3, plus 1 is 4. So 4 plus 10 is 14, right? So 4, carry the 1 to this column. Now let's add this column. Do we see anything that adds up to 10? No. So let's just add as usual. So 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3 is 7. And 7 plus 1 is 8. So put that 8 right here. Okay. Let's add this column. Anything gives me 10? Does anything give me 10 here? Yes, right? 2 plus 8 is 10. 10 plus 1 is 11. Good. Okay, and then carry that 1 for the 11, and 1 plus 0 is 1. So what's my answer, right? So look, again, start from the right, and you're going to go 1, 2, 3, comma, right? Remember, but you don't need a comma to make the answer correct, but you get the idea. And we have 118,404. Okay, there's the answer. So 118,404. And there you have it, using the lattice method. Okay, there is the answer. Okay, everybody, it's that simple. Okay, it is that simple. If you like this method better than the standard algorithm, then use it. Okay, let's do another example. All right, let's do another example. How about this one right here? 3,791 times 562. Okay, work along with me, ladies and gentlemen. All right, remember, we learn math by doing, not by watching. All right, so again, I need to create a grid. Okay, but this time, the grid's not going to be a 3 by 3. It's going to be a 4 by 3. Okay, 4 digits and 3 digits. Now you might say, well, Mr. Barbier, do I make it 4 columns going down and 3 columns going, 3 rows going across? Or do I make it 3 columns going down and 4 rows going across? The answer is either is acceptable, but my recommendation is if one number has more digits than the other, then the one that has more digits, let that represent your columns going down. So since I am creating a 4 by 3 grid, let's have 4 columns and 3 rows. Okay, so let's do that. So we're gonna create, let's see, let me put it right here. We're gonna create so I'm gonna create 4. That should be long enough, right? That's 4. So look, I'm gonna have 3, 7, 9. Make sure you don't make them too scrunched up together. 1. Okay. By what? By 3. Right? By 3. So 4 by 3. So 5, 6, 2. Now let's complete the figure. This time we're going to have a rectangular figure instead of a square because you know the sides are not equal in length, but that's okay. All right, and now let's finish the columns. So I have a column here for the 3, and here for the 7, and here for the 9, and here for the 1. Okay, and now let's zoom in on that. And now let's make our rows across. Okay, and now let's not forget the diagonal columns. Let me use another color for this. So find the corner and extend. Now remember we go corner to corner, extend, right? Corner to corner to corner, extend, and just keep going. Okay, there we go. Beautiful. Now, ladies and gentlemen, now's the time in this video where I'm going to tell you to pause. Pause and fill in the squares yourself. Okay, ready? Pause. Okay, I'm looking and I'm watching you. Okay, I'm watching you. Pause the video. Fill in these squares the way we did the top one. Go for it. All right, I'm going to assume you did fill in the squares and you're ready to see if your answers are correct. So remember, you can fill in these squares in any order as long as you know that the number across and the number above, wherever they meet, is where you put the answer, correct? So what goes here? Someone just said 15. Very good. That's 3 times 5. What goes here? Someone just said, Mr. Barbier, it's 3 times 6, which is 18. What goes here? Someone just said, Mr. Barbier, that would be 3 times 2, which is 6. So it's going to be 0, 6. Very good. All right, there we go. I'm going to change pens because my purple pen's running out of ink a little bit. What about this square? Someone said, okay, Mr. B, that's 7 times 5, 35. This one? Okay, someone said 42. Good. This one? Someone said, okay, Mr. B, 7 times 2, 14. This one? Okay, very good. 45, 9 times 5. This one? Someone said 9 times 6, 54. This one? Okay, very good. I heard you. 18. This one? Someone said 05. This square here? Okay, very good. 06. This square here? Okay, 1 times 2, that would be 2. So 02. All the squares are filled. If you got that right, give yourself a pat on the back. Okay, I'm just going to write on top of these real quick to make everything the same color. Okay, there we go. So now we're going to add the diagonal columns going from left to right. Okay, in this diagonal column, all you see is a 2. So drop it. In this diagonal column, what do we have? Okay, good. 6, 0, and 8. So someone said, Mr. Barbier, that would be 14. Again, look for numbers that give you 10. So what gives you 10 here? Okay, someone just said, well, Mr. B, 5 plus 4 is 9 plus 1 is 10. Good. And 10 plus 4 plus 1, which is 5. So 5 plus 10 is 15. That's right. Again, in this column, what gives me 10? Okay, very obvious. 5 plus 5 is 10. So let's add the other digits. 6 plus 1 is what? 7 plus 2, 9 plus 1, the one that we carried, is 10, and 10 plus 10 is 20. Good. 0, carry the 2. I'm trying to squeeze it in somewhere here. Okay, right away you see it, right? 8 and 2 is 10. 4 plus 5 is 9, so 9 plus 10 is 19, right? We don't have to pay mind to the 0. 19, so 9, carry the 1. We have 5 plus 3, which is 8, plus 1, which is 9, plus 1, which is 10. And then 1 plus 1 is? Okay, good. 2. Okay? And ladies and gentlemen, that's it. That's it. We're done. So what's the answer? Let's start from the right and count 3 places. 1, 2, 3. Put a comma right here. And then look again. 1, 2, 3. Put a comma right here. And there's our answer. So let's rewrite it. It's 2,090,542. Okay? So 2,090,542. There it is. Very simple, very simple. So ladies and gentlemen, one last thing I want to show you before this video ends. Okay, first of all, let me say this real quick. If you got that, if you understood it, you're in good shape. You should be able to do both sheets of homework, no problem. Look at the first sheet. The first sheet is all lattice. The grids are made for you if you use, this sheet, if you're able to print it out, or if you're able to use the markup tool on your cell phone or iPad, you can do so. If not, you'll have to make the grids. And you should actually practice making the grids, to be honest, okay? So notice there's 8 problems here. These are all 3 by 3, right? 3 by 3 grids, because every problem is a 3-digit times a 3-digit problem. 3-digit number times another 3-digit number. But, ladies and gentlemen, I didn't stop there. You have this one as well, okay? So this whole worksheet is a 4-digit by 3 digits. So 4-digit number times a 3-digit number. Again, 4 columns going down, 3 columns going across. The first one's done for you, okay, in both worksheets. You can ignore the first problem. Let me make that clear. You don't have to do this one or this one. It's already done. Do the other ones. But before I end this video, I want to show you one last thing. Some of you might be wondering, Mr. B, how do you multiply decimal numbers using lattice? Let's do it. Okay, here's a decimal problem. 8.47 times 9.3. Now, the good news is we do the same thing with lattice that we do with the standard algorithm method, and that is we multiply them to start as if there are no decimal points there, meaning multiply these two numbers as if they are whole numbers. We do the same thing when we are solving using the standard algorithm. We do the exact same thing. Nothing changes, okay? So let's make our grid to the side, all right? So this time I'm going to have a what by what type of grid. Is it going to be 3 by 3, 3 by 4? Okay, someone just seems to be, it's going to be a 3 by 2. You're right. So let's do it, 3 by 2, okay? So we're going to have 3 columns going down for the 847. And then we're going to have 2 digits. So 2 rows for the digits going across. All right. So let's finish making the grid. Some of you, I'm sure, will be able to make this grid a lot faster than I've been making it during this video. Okay, I've had students who can make these grids very quickly. As a matter of fact, once you get used to it, it becomes pretty fast. There it is. Okay, now again, let's multiply as if it's a whole number times a whole number. All right, let's do that. Pause the video. Ladies and gentlemen, as always, pause the video. You do it. Go for it. Okay, I'm going to assume you did it. Time's up. Let's do this. Okay, let's go. This box. Someone just seems to be 72. This box. Good. 24. This box. Okay, 36. This box. 12. Very good. This box. 63. Very good. And this box. 21. Someone's been working on their times tables. Thank you. Keep working on those times tables. All right. So, let's continue. Let's finish the problem, and then we'll pay mind to the decimal. Let's come back to that. So do the addition part. Okay, someone's telling me Mr. Barbier dropped the 1. 3 plus 2 plus 2 is what? 7. Very good. 6. Do you see any 10s here? Someone just said Mr. Barbier. 4 plus 6 is 10. 1 plus 6 is 7. 7 plus 10 is 17. I heard you. Very good. Okay, so we have 1, 3, 2, and 2. Someone tell me. 8. Thank you very much. Okay, and then finally, we have the 7. Just drop it. So, ladies and gentlemen, if we were multiplying 847 as a whole number times 93 as a whole number, the answer would be 78,771. However, it isn't a whole number, right? Let's look back. It's actually 8.47 or 8 47/100ths times 9.3 or 9 3/10. So how do we do that using lattice? Well, the decimal, notice, for the 8.47 goes here. Notice I'm putting the decimal point right on top of this line here, this little path that I'm going to use in a minute. The 9.3, the decimal goes here. Again, I want to line up the decimal with this line right here because I'm going to use this path in a minute. Now you might say, Mr. Barbier, why do you keep saying path? Watch. Because what I'm going to do is this decimal is going to follow this trail, like it's just walking down the trail, walking down the trail, walking down the trail, and I'm going to stop here. Now you might say, Mr. Barbier, why are you stopping there? Because this decimal will follow this trail. Now here's the thing. What I want is I want the two decimals trails to meet. That's what I want, okay? If this decimal were down here and I followed this trail, then obviously this trail and this trail would meet here, right? That's the difference. So just keep that in mind, right? So this decimal follows this trail. This decimal follows this trail. They meet at this point, and then watch this. Now I go diagonally down the diagonal trail. And this, let me draw a little arrow. And this arrow is pointing to where I'm going to put my decimal point. See that? That's how you do it using lattice. So the answer is 78.771 or 78 and 771 thousandths. Okay? That's how you do it. So let's put the answer over here. So 78.771. And there we have it. Okay? And folks, there it is. As a matter of fact, I just realized, whoops, sorry. I forgot to box my first answer up here. So ladies and gentlemen, that's how you multiply whole numbers and decimal numbers using the lattice method. So your homework does not have any decimals on it, so no, you don't have to concern yourself with that. Everything is multiplication of whole numbers, but you know what? Now you know, in case you ever have to multiply by a decimal, you know how to do it. Okay, using the lattice method. All right, so ladies and gentlemen, it's all up to you now. You're gonna practice by completing both of these worksheets. You can do this, I know you can. Have confidence in yourself, you're doing great. Keep being great because you are, and I'll see you in the next video. Take care.